Good morning friends, heartily welcome to my YouTube channel. So previous sessions, as we all know, we have been discussing about the determinants, right? So we have completed two exercises. It was a long journey. We have finished two exercises, right? Let's proceed with the next part, the next topic, so which is nothing but area of triangle. So area of triangle in the sense, the one and only one formula which pop up in your mind is half base into height. This is the formula which will come into your mind. Okay. So, but this, my friends, this is not the only formula to calculate the area of any triangle. So, area of triangle can be calculated using variety of formulas. Right? There are 2 to 3 formulas by which you can calculate the area of triangle. Right? And that depends on what are the inputs you are having. So, this is possible only if sides are known. Only if sides are known, then you can calculate that. But apart from this, one more famous or one more continuously which is asked, right, is the vertices. When the coordinates of vertices are given, when the coordinates of vertices are given to you, then how are you going to calculate the area of triangle? So when vertices are given, you can try that in two methods. First one is use the distance formula. When you know all the vertices of three vertices of a triangle, okay, for example, if this is the triangle A, B, C, x1, y1, x2, y2, x3, y3. So suppose vertices are given, then there are two methods to find the area of triangle. First one is, there is a lengthiest method. Using these vertices, find the distance. Once you get distance, substitute in this formula, right? Then you can have the you can get the value of area of triangle. Now coming to second method, right? There is use of formula, right? So use of formula. What is that? This also you have studied, but this came in your previous sessions, right? Previous in your schooling, high schools and all. But I hope you have forgot this one, right? So I don't think you remember. But if you remember, that is well and good. Or else you can refer this one: half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula, right? So directly you can substitute x1 y1 x2 y2 and x3 y3 in this formula to get the value of your area, right, of the given triangle. But apart from this, there is one more method in the determinant. Okay, there's one more method in the determinant which you can make use, right? So in determinants, so area is given by half into x1 y1 1 x2 y2 1 x3 y3 1. Okay, so this is the formula which is given to calculate the area of triangle in your determinant, right? So throughout our chapter, throughout this determinant unit, we are going to make use of only this formula, neither this nor this. We are going to make use of only this formula to calculate the value of derivative. Okay, this is just the thing. Directly you can substitute here, and there is a 3 cross 3 determinant. You know how to calculate its value, right? So there's no way, there's no need to once again explain me the method of calculating the value of this determinant. Already you know how to do it, right? So let's proceed with some examples. Okay, and one more point here is, we are also making use of this area concept of a triangle to check whether the points are collinear. So what are the collinear? What do you mean by collinear points? The points which lie on the same straight line. The points which lie on the same straight line, we refer them as collinear points. So we are going to make use of this area concept, okay, so to find whether the points are collinear. How to make use of this concept to find the area of to find the points whether they are collinear or no. Okay, so collinear means the points should be lying on the same line. If they are lying on the same line, then we call it as collinear system. Alright, so now this one is there. Consider this triangle. If I press this A downwards, right, a little bit, then what happens? Let this be 1. Keeping B and C same way, I'm going to press A inside. It will come this way. Still if I press it down, it will come in this way. This is 3. So still if I press it down, this will look somehow this way. Okay. So still if I press, right, if I totally press it, how it will be there? B, A, C. If I totally press it down, then this point A will lie on the point BC, on the line BC. Now compare this all figures. This is sixth one. Compare all the values, okay, A, B and C. So the first triangle is bigger compared to the second one. Second is bigger compared to third one. Third one is bigger than fourth. Fourth is bigger than fifth, and fifth one is comparatively bigger than sixth. Right? So as first one is bigger than second one, first one is having more area compared to second one, and second one is bigger than third, so second is having more area, and third is bigger than fourth, so third is having more area, and fourth is bigger than fifth one, so fourth is having more area, and fifth is bigger than sixth, so fifth one is having bigger areas. So I can write A1 is greater than, A2 greater than, A3 greater than, A4 greater than, A5, okay, and which is greater than A6. So A1 is greater than A2, A2 is greater than A3, so on, and least area is A6, right? But now observe what is the area of this triangle A6. It goes on reducing, and when the point A lies on the BC, the area of triangle becomes 0. We don't have any triangle here. You can see BAC is not a triangle. It is no more a triangle. It has become a straight line. BAC has become a straight line. There are points on the straight line. There are no more the vertices of the triangle. Right? So when there are no more the vertices of triangle, then the area will not be there. So when area is not there, what does it mean? So mathematically you cannot say area is not there. You can say that area is 0. Right? So no area in the sense the value of area is 0. So if you want to check whether points are collinear or no, then you have to equate its area as 0. Right? So use this formula, equate it to 0, calculate the determinant. Right? So you calculate the area value. If it is coming out to be 0, then you can say that the points are collinear. Right? What is the condition for points to be collinear? The area should be equal to 0, area of a triangle. If you consider them as triangle and then calculate, their area should become equal to 0. That is the main concept here. Okay, so this is how it will be there. So calculate the area. There are two types of problems coming in collinear things. They will ask you calculate prove that they are collinear. Then what you should do? Use this formula. Okay, then calculate its value and prove that the value of the determinant is 0. If you are able to prove that the value of determinant is 0, then you can proudly say that the points are collinear. Okay, that's one thing. Second type of questions which are coming over this one is, they themselves will give you that the area of triangle is collinear, that the points are collinear. Then they will ask you to find any one of the vertices, any one of this value, x1, x2, x3, y1, y2, y3. Out of this thing, any one value they will ask you to find out. Right? Then what you are supposed to do, as they themselves said that the area, the points are collinear, directly equate it to 0 and calculate it as an equation. Then you are going to get the values. So don't worry, we are going to solve both the types of problems. Right? This is for your information. This is about the introduction of the area of triangles. So I hope you have understood this one. Right? So now pause the video for a moment and make a note of this. Okay friends, so I hope you have understood the concept. I hope you have taken down the notes, everything. So let's see some examples based on this concept, based on the area concept. So what is given here? So find the area of triangle whose vertices are 3, 8, minus 4, 2 and 5, 1. So if the vertices are 3, 8, minus 4, 2 and 5, 1. So we need to find the area of triangle. Let x1, y1 is equal to 3, 8, x2, y2 is equal to minus 4, 2 and x3, y3 is equal to 5, 1. Okay, so let us assume that these are the vertices. Okay, so given vertices we have assumed as x1, y1, x2, y2 and x3, y3. Then area will be equal to, area is given by half x1, y1, 1, x2, y2, 1, x3, y3, 1. So this is half. What is x1? That is 3. What is y1? 8 and 1 as it is. x2 is minus 4. y2 is 2. This 1 as it is. x3 is 5. y3 is 1 and this is 1 as it is. Okay. So one more thing you have to remember. Sometimes when you calculate the determinant, as we have seen, right, due to some positive and negative values, you may get the determinant value as negative. But this determinant, whatever we are using here, this is not just the determinant, this is area of triangle, right? So area means always a positive quantity, right? It is always a positive quantity. So whenever you get negative, so either put it in mod or neglect that negative sign. Okay? So only you have to consider the magnitude. Negative sign only indicates the direction. That means it is negative because some of the part of triangle may be in certain negative quadrants, so you will get negative value, but don't keep it as negative. So either you should put it in mod and convert it as positive, or directly you write it as positive. Okay, so now area will be equal to half into, okay, so expanding through first row, so what will be there? This is plus minus plus, that is 3 into, what is determinant? Leaving first row and first column. 3 is there in first row and first column, so I am neglecting first row and first column. So what is there? 2, 1, 1, 1 minus 8 into, so 8 is there in first row and second column. Neglect first row, second column. So what do you get? Minus 4, 1, 5, 1 plus 1 into, so this 1 is there in first row and third column. Neglect first row and third column. Minus 4, 2, 5, 1. Okay, so this is how it will be there. So it is half 3 times of, this is what? 2 into 1 is 2, minus 1 into 1 is 1, minus 8 into, minus 4 into minus 4 into 1, minus 4, minus 5 into 1, 5. Okay, plus 1 into, minus 4 into 1, minus 4 minus 5 into 2, 10. Okay, so this is nothing but half 3 into 1, right? Then, or I will write it more comfortable, 3 into 1 minus 8 into, what is minus 4 minus 5? Minus 9 plus minus 4 minus 10. So it will be minus 14. So this is nothing but half 3, 8 into minus 9 plus 72, right, minus 14, right. 72 plus 3 is 75. 75 minus 14 is 61. So this is 61 by 2 square units. Required area is what? 61 by 2 square units. So this is how the area is to be found out. So what you need to do is, this is one more thing, always write square unit. Don't forget to write don't forget this thing to write, right? If you forget, then you may lose the marks. So area is unit of area is a square units, right? So always remember that to write at the end of your answer. Okay, so pause the video and make a note of this. So friends, so I hope you have understood that previous problem. Let's start with the next one. So what is given over here? Find the equation of line joining A 1, 3 and B 0, 0 using determinant. Right, this is the first part. Right, first we'll deal with that and we'll move on to the second one. So when you want to find an equation of line, so if it was not a method of determinant, then directly you can use the distance formulae and you can calculate the equation of line, right? Or that is y is equal to y2 minus y1. That's formula, whatever is there, you can use it. But here we are not supposed to use that formula. We need to apply the methodology of determinant to get this one. So if I want to apply the determinants, then I need to assume, right, an arbitrary point in between the line AB, right? So because I need to make use of determinants, right, there is one formula for determinant by which we can calculate the area that we have already discussed here. Okay, so to use that formula, what we need is, we need 3 points, 3 vertices of a triangle, right? And we know that if the points are collinear, then the area of triangle will become equal to 0. So now assume an arbitrary point in between A and B on the line AB, so that the point which is assumed, the point A and B becomes collinear. Then use the area formula for collinear points, then you can find the equation, right? Let P x comma y be the point on line AB. Now A 1, 3, B 0, 0 and C or P, we have assumed P x comma y are collinear, right? So what is the area formula? Therefore I can write half x1 y1 1 3 1, x2 y2 0 0 1 and x y 1, okay, is equal to 0. So now expand it through second row. Expand it through second row. Why? Because maximum number of zeros are there in second row. Expand it through second row. Half into second row. This what will be sign convention? Minus plus minus. So minus plus minus. These are 0. Leave it. Minus 1 into. So this is there in which row? Second row and third column. So leave second row, third column. What is left? 1, 3, x and y is equal to 0. So this implies half, right? Or minus I will take out. 1, 3, x y is equal to 0. Okay, minus comes on the other side, it becomes plus. So this half is not equal to 0, so determinant will be equal to 0. 1 3x y is equal to 0. So this implies y minus 3x is equal to 0. Right? This is the equation of the straight line. Okay, this is the equation of straight line. Y minus 3x is equal to 0. So this is the first part. Coming to second part. What is there in second part? Find k if d k comma 0 is a point such that area of triangle ABD is 3 square units. This is general methodology. Okay. So we need to find k if area of the triangle, right, ABD is 3 square units. Okay. Let x1 comma y1 is equal to 1 comma 3, x2 comma y2 is equal to 0 comma 0 and x3 comma y3 is equal to k comma 0. Okay. So now area is given by what? Half x1 y1 1, x2 y2 1, x3 y3 1. So this implies what is our area? Area is given as 3 square units. Half into what is x1? 1, x2 0, x3 1, right? And what about x2? 0, right? Sorry, x1 is 1, y1 is 3. So x1, y1, 1. x1 is 1, y1 is 3. x2 is 0, y2 is 0, 1. x3 is how much? k 0 1. Okay, I hope you got this one. So I bring 2 on this side, so this will be 6 equal to 1 3 1 0 0 1 k 0 1. Okay, so now once again expand it through second row. Okay, expand it through second row. What we get? This part. This is minus plus minus. So minus 1 into what is the determinant value here? So minus this one is there in second row and third column. So leave second row, third column. What remains? 1 3 k 0 is equal to what? 6. So now minus 1 into 0 is 0, minus k into 3 is 3k is equal to 6, minus into minus plus 3k is equal to 6, k is equal to 2. 6 by 3, that is nothing but 2. So this is how you need to solve it. Okay, so I hope you have understood this one. So pause the video and make a note of this. Okay. So friends, I hope you have understood this one. So we'll stop the session here. So this was about the concept of area. So whatever problem is given, different times we have taken, and also when we deal up with the exercise in next video, we are going to start with the exercise, that is third exercise, so that all the problems, all the varieties coming on area of triangle will be much clearer to you people. Okay, so with this we'll stop the video, right? So we'll take the leave at this point. Okay, so goodbye, take care.